Transformation of function graphs, part 2. We have a function f of x and we need to expand or stretch it on the x-axis by 2. Do you remember the last session? I told you x is no, so anything happen to it will be inverted inside the f of x. Okay, this is the f of x, this is point -2 and 3, this is point 0 and 0, and this is 2 and 3. This is the f of x. Now to stretch the x, we multiply it by half inside the brackets. But what actually happened to the x, it will be multiplied by 2. So the first point will be 0 times 2, will be 0 and 0. And second point, -2 times 2, and the y will remain the same, will be -4 and 3. Then the third point, 2 and 3, 2 times 2, will be 4 and 3. This is f of x times half. We have function f of x and we need to expand it or stretch it on the y-axis by 2. You remember, y is yes. This is the same f of x multiplied by 2. So 0, first point, 0 and 0 will be the same. The second point, -2 and 3. Y-axis will be multiplied by 2, will be -2 and 6. Your point will be here. The last point, 2 and 3, 2 and 6. The new point will be here. This is the new function, f of x all times 2. We have a function f of x and we need to expand it, stretch it on the x-axis by 2, by the y-axis by 2 and the x-axis by 4. So the new function will be f of x times 1 over 4, as we expanded by 4 in the x-axis. Remember, x is no, so everything happened to the x is inverted. Then times 2, all of f of x times 2 to expand it in the y-axis. First point will be multiplied by 4, x and 0 will be remain the same, 0 and 0 will be here. And second point, -2 and 3, 2 times 4 and 3 times 2 will be here. And the third point, 2 and 3 will multiply the x by 4 and the y by 2. We will have 8 and 6. This is the new function. You see, it became wider and taller than the last function. Now we're ready for compressing a function. But first, we need to confirm this information. To expand a function, we'll multiply it with a number bigger than 1. Of course, f of x. As an example, 2 times 5 equals 10. A number higher than 2. Yes. To compress a function, we multiply it with a number smaller than 1. Let's say a decimal or fraction. As a number 2, as an example, 2 times 0.5 equals 1. Less than 2. But don't forget, everything is inverted in the x-axis. Remember, as I said in the last session, x is no. So everything that happened to the x inside the f of x will be inverted. Okay, to compress it, we multiply with a number bigger than 1 and smaller than 0. I'm sorry, smaller than 1 and bigger than 0. Now we have function f of x and we need to compress it on the y-axis by 2 and the x-axis by 4. This is the last function. We have the point -8 and 6, 8 and 6, and 0 and 0. We want to compress it in the x-axis, we multiply it by 4, and we want to compress it in the y-axis by 2, so you will multiply it by half. So 0 times 0.25, It's also 1 over 4, and 0 times 0.5 remain the same. The new point will be here, and 8 times negative 8 this point times 0.4 and 6 times 0.5. So the new point will be here, and the last point 8 and 6. Multiply 8 times 0.25 and 6 times 0.5, so the new point will be here, 2 and 3. Reflection on the y-axis. Let's see this object f of x. We have a mirror. It will be reflected on the y-axis. It will be f of negative x. See here, 4 will be negative 4, 5 will be negative 5. It's reflected on the y-axis. Consider the y-axis as a mirror, a big mirror. Okay, let's take an example here. We have this point 0 and 2. 2 and 0, I'm sorry. We want to reflect it on the y-axis. So we multiply the x value by negative 1. It's negative f of negative x. So negative 1 times 2 will be negative 2 and 0. So the point will be, new point will be here, negative 2 and 0. And the old point is here. Just as a mirror. Consider the y-axis as a mirror. Reflection on the x-axis. Now we have the same object, f of x, reflected in the x-axis. Consider the x-axis as a lake. You see yourself down there. It will be negative f of x. Do you notice something? When we give x a negative value, it will be reflected on the y-axis. When we give y a negative value, it will be reflected over the x-axis. You see the point 0 and 3. Reflect this point in the x-axis. So we multiply the y with a negative 1. So 0 and negative 1 times 3. It will be 0 and negative 3. The new point will be here. The old point is here. Just as a lake. Just as a lake. Consider the x-axis as a lake. But what if we want to do the both? Reflection on x-axis and y-axis. At this point, it will be reflected over here, then over here. So what do you think will happen? Yes, multiply negative f of negative x. It's reflected 2 times over the x-axis and the y-axis. And if this object was f of x, it will also be reflected over here. Now let's take an example. You see this point 2 and 3. I want to reflect this point in both x-axis and y-axis. You multiply both by negative 1. So negative 1 times 2 and negative 1 times 3. So it will be the new point will be negative 2 and negative 3 over here. This is the new point. You can consider the origin point as a crystal that reflect an object 2 times. It will be reflected over here, then over here. Exercise 1. We have function f of x and we need to reflect it in the y-axis. This is f of x. To reflect it in y-axis, we have f of negative x. Negative 1 times 0 and 3 remain the same, 0 and 3. The new point will be here. Then this point, negative 1 times 3 and 0, will be negative 3 and 0. So the new point will be here. And you see that? Just like a mirror. Imagine the y-axis as a mirror. Exercise 2. We have a function f of x and we need to reflect it in both x-axis and y-axis. Okay. This is the function f of x. Be negative f of negative x. Negative 1 times 0 and negative 1 times 3. So the new point will be 0 and -3 here. For the other point, multiply -1 times -3 and -1 times 0. Be 3 and 0 here. Negative f of negative x. Yes, in this exercise we will do everything. Expand the function by 2 in the x-axis, reflect the function on the y-axis, compress the function on the y-axis, shift the function 2 points up. Okay, to expand the function by 2 in the x-axis, we multiply the x inside the brackets by half. Remember, x is no, so everything will be inverted. And you'll understand it more when we enter the inverse of the function. Reflect the function on the y-axis, multiply the x by -1. Then compress the function on the y-axis, we multiply half to all of x. Then shift the function 2 points up, we add 2. Now, this is the function 0 and 6, and -3 and 0. Okay, this is f of x. Now, what we will do to the 0? Time -2, right? Because 1 over 2 will be inverted. But the negative will remain. Remember that. The negative will remain. Okay, for y-axis, for the y, we multiply by half, and then add 2. So the new point will be 0 and 5. Here. The other point, -2 times -3, this point, and 5 times 0, 0.5 times 0 plus 2. The new point will be 6 and 2. Here. Thanks for listening everyone, and have a nice time.